Good day, so I'm going to present the embedded computing coursework for assembly programming. So for the task given, I need to design an embedded system software for simplified model of a conveyor belt driver, and the task will be solved with flowchart and writing the codes on MPLAB, and it will be implemented on PIC SimLab with PIC Genius Board. So the task will involve the use of 2 buttons, 3 LEDs, 1 7-segment display, 1 potentiometer, and 1 fan on the PIC Genius board. And below are the 4 states that we need to achieve during the coursework. So for the first state, we need to press a button to indicate that the device is switched on. And when the device goes into the first state, 1 LED should be light up immediately and display a 1. And for second stage, we need to turn the potentiometer to a range of greater than or equal to 2 times A times 0.1 volts. So for the values of A here, it is the last student ID, the last number of our student ID. So for me, I'm 5. So after times together with all the value given here, I'm getting 1 volts. So for the second stage simulation, the conveyor belt is operated in the forward direction. And in this stage, the LED which we simulated during the first stage will still remain light up. And another LED will light up also, and it will display 2. And for third stage, we need to turn the potentiometer to a range of greater than or equal to 3 times A times 0.1 volts. So I'm getting a 1.5 volts here. And the operation of the conveyor belt is still the same with the second stage, which is operated in the forward direction. But the difference is for this stage, we need to switch on the fan with a B kHz frequency. So for the number of B here is the second last number of my student ID. So here I'm getting 6 kHz of frequency to switch on the fan with 40% of duty cycle. And in this stage, the first LEDs that we simulated in the first stage will remain light up, but for the LED that we simulated in second stage will turn off, and another LED will light up here and will show a 3 on the 7-segment display. And the last stage is to press a button to close everything, so the button will act as a stop button. So now we will look into the flowchart. So this is the flowchart for the stage 1. So first we start the program. It will initialize all the registers like 8con1. So this is for the 7-segment display. And next we need to initialize the ports, which is analog for ADC. So this is used for 7-segment display also, to change the analog to digital, so we can display the number out. So we will now press the RB3. RB3 is one of the buttons that I'm set in the PIC Genius board. So when we press the button, here we go to the function here, MOVLW, binary number of 1. So it will display a 1 on the 7-segment display, and LED on the port V, the third LED on the port V will light up. So 1 LED will be light up and display a 1. So after I release the button RB3, it will clear the port B, which all the program here will terminate, and back to the first one. And for the flowchart of second state and third state, still the same. We need to start the program and initialize the register icon1 and icon0, which is for the ADC, and CCP1 CON and T2 CON for PWM. So we need to initialize the ports, analog for ADC and CCP1 for PWM. So the function here called ADC subroutines, and then the function shows here is used for to convert the analog to digital, so that we can display the numbers on the 7 segment displays. And ADRESHW here is a calculation and a function that we use for the adjustment of potentiometer. We need to calculate it and set the range of the potentiometer. So we need to use this function BTFSS status to set the potentiometer adjustment. So for my task, for the value I'm getting, my range is within 1 volts to 1.5 volts. So if it is over or greater than the 1.5 volts, if it goes to the PWM function here. If on the other side, if it is equal to 1 or less than 1 volts, if it goes to the function here, which is displays number 2 on the 7 segment display, and the LED that we stimulated during the first stage will remain light up, and another LED will light up here. So I'm choosing the first LED on the port V lights up. So 2 LED will light up, and the display will show 2 when returning the potentiometer to greater than or equal to 1 volt. So here we were looking at the PWM subroutine flowchart when the potentiometer is adjusted greater than or equal to 1.5 volts. So we will start the PWM and setting the register according to the PWM period, which is 49 after the calculation and 40% duty cycle. So when we're turning the potentiometer to greater than or equal to 1.5 volt, it will go to a function here, which is used to display number 3 on the 7 segment display. And here a new LED will light up. So I'm choosing number 6 LED. So the LED for the second stage will turn off now, and the LED during the simulation on first stage will remain lights up here. At the same time, the PWM will be generated, and it will return to the main program for the second stage and third stage. So now we will look into the code. So this is the code for the stage number 1 and 4. So we need to access to the bank 1 and clear all the trees D and the trees B and make the RD3 light up. So the trees D3 here, BCF trees D3, is to set the number 3 LED, the third LED here, as an output, and BCF port V3 is to set the RB3 buttons as a switch. So we need to set this as an input and this for the as an output. And NOV LW 0 times 06 and the ADCON 1 here is set the port A, which is in analog to digital. And the BCF trees AA2 is we need to activate, and we select the first 7 segment display. So next, check PBTFSC port V3 this is a function that we use to check if the RB3 button is pushed. So it will display number 1 on the 7 segment display, and the LED3, the RD3 will be light up. And if it is not be pushed, and nothing will happen here. That's why we use the BTFSC function. And that's all for the code of first stage and fourth stage. And next we will go to the stage, the code for the stage 2 and 3. So the C block here and the buffer1 function is used to define a variable to hold a value. And first we go to start. So it's the same. We need to register bank 1 and make all the port B and D as output. So the MOVLW binary number here, left justified, is used for the potentiometer adjustment, and the ADCON 1 is used for the analog to digital purpose. So the A2, trees A2 is set as a digital output, and after that we need to select bank 0 for another analog to digital purpose. So here state 3 is the code for state 3 to generate the PWM. So we will set 3C2 as the output, and we will set the 49, which we're getting our PWM period in the calculation here. And then we will set the CCP1 CON2 to PWM mod. And the function here also is for the PWM purpose. And we will set the mem loop here as a delay for the A2 ampere to settle and capacitor charge. So first we will wait for 5 microseconds, and then it will wait 1 microsecond respectively. After that, we will check and copy the buffer here. We will use the MOV FADREH 0 here to copy the 8 bits most significant binary to buffer. So we will check, go to the next function here. So we will copy the buffer here for display purpose and copy to W register for processing. After that, we need to clear all the port D and B, and then we will put the potentiometer adjustment here, which is getting 1 volts and getting 187 decimal number. So we will put the binary number here, which we calculated for the potentiometer here for the range of the adjustment. And then we will go to a 2 display and 3 display. So here the code here is for the potential adjustment. And now we will go to the output of the code for the states. So the 2 display here, we will when the potentiometer is adjusted to 1 volt or less than 1 volt, it will display a 2, and 2 LED will be light up, which is in 3B 1, 3, 1 and 3. So the first and the third LED will be light up here. And then in 3 display, it will display a 3, and the LED of third and 6 will be light up here. So the LED for the first one will be turned on in the third state. And the codes below here, the function below here, is for the generated is used to generate the PWM. So that's all for the code, and we will now looking into the results. So I'm now showing the results for the first state. So these RB3 buttons is the button that I mentioned earlier. So when I push it, the LED 2 in port B, the B3 will light up and the display will show 1. And when I release it, the B3 will light off. And now this is the result for the second state and third state. So when the potentiometer is within the range of 1 volt or less than 1 volt, the display will show 2, and the LED, 2 LED will light up, which is the LED that we simulated during the first state, and another LED that we use in the second state. So now I'm tuning the potentiometer. When it is over the range or equal to 1.5 volts or greater than 1.5 volts, the display will show 3, and the LED that we simulated during the second state will now turn off, and another LED will light up. And for the LED B3 will remain light up here. So at the same time, the PWM is generated to switch on the fan. So that's all from me. Thank you.